I would like to Mr. Francic for his next session for Teknokroma presentation.
She is Gemma Castelvi.
Yes, my name is Gemma Castelvi. I am from Spain, from Barcelona. Okay, I'm working in Teknokroma, and I am the sales responsible for Bangladesh area. Okay, and we are invited from Mr. Rosen from Chemtech, so we are going to explain a few minutes, 1 hour, our products. Okay, hope you enjoy. Okay, my manager is going to explain.
Yeah, okay. So, yes.
Yes. Okay. Now it's my turn. My name is Francesc. Also, I'm from Barcelona, from Spain. And yeah, for us, it's for Gemma, for me, it's a pleasure to be here. Yesterday, we have the opportunity with Chemtech to visit some pharmaceutical companies. One is here with us, and really it was a pleasure. It's our first time in Bangladesh, and we have felt very comfortable. And let's see, we will try to do our best in order that to have a good time here. Okay, so again, thank you to Chemtech from the invitation for organize this, and also it's nice to see, here all of you, and we are happy to be here, as I said before. Okay, before to start, this is my Teams. Somebody from Spain has started to wake up, okay? But they know that I'm here. Our intention is to talk a little bit about chromatography, about GC chromatography and HPLC chromatography. But before, I would like to know a little bit from you, okay? So, for example, who of you are working with HPLC? Can you put your hands up? HPLC. Okay? Yeah. Who is working with GC? Okay. The rest are working, or yes? So GC, HPLC. Okay. So which sectors are you from? I know that there are some companies that are pharmaceutical companies, for example. Then which other sectors? If somebody can say which sector, if it's food or environment or textile. Pharmaceutical. Okay, who from pharmaceutical? Can you? Oh, yeah. I have seen. We saw yesterday really very big pharmaceutical sites here in Bangladesh. I know Mr. Roshan for a lot of years, and tomorrow I will fly to India, okay? And this time I will not visit pharmaceutical industries, but I know that these countries from this region, Bangladesh, India, Pakistan, and other countries, there are really very big pharmaceutical sites. So for me as a Spanish, okay, as a Spanish that Jem and me we are, so we say, come on, this country has a power of manufacturing pharmaceutical drugs, unbelievable, okay? I say you that in Spain there are some pharmaceuticals, but there are not big pharmaceutical sites like here, okay? So pharmaceutical site, a lot of people has put hands up. Who else? Textile, who is from textile, or laboratories that look textile? No? Yes. Yes, okay, good. Well, which company?
I'm the testing industry.
Testing industry, yes, okay.
AGS.
SES, oh, yeah, oof, very big company. Yeah, we had the opportunity to be at SGS of Karachi in Pakistan. Very big site. And also SGS Peru in South America. Also we have been there. Good. SGS and then so somebody else that it's not in a pharmaceutical, it's not in SGS, it's not in textile, but it's working. Okay. So which other sectors are here? Universities, perhaps, government laboratories? No? Okay, perfect. Petro, somebody from gas, oil, petro? Also gas, oil, petro, they are doing chromatography? Okay, fantastic. Thank you for your participation. What you would like we start with? With GC or with HPLC? GC? No, HPLC. I was imagining, yeah. I was imagining. Okay, I would like to first to do a short introduction of our company. Okay. Okay, we are from here, from Spain, from Barcelona, and our company, the headquarters and the manufacturing sites are in Europe, in Spain, Barcelona. Okay. Also, we have Teknokroma Portugal, our country, that is our neighbor country, and then 3 years ago we established in India a sales office, branch office. It's to cover, as you know, also the pharmaceutical industry in India. It's powerful, like Bangladesh, like Pakistan, like other countries, and we have an office in Delhi. Then this is a picture of our building. Actually, there is 80 people, and in the same way as Chemtech. Some of us, we are chemists, or we are pharmacists, or you know, any different kind of disciplines as in all of your companies there are, right? So we were the company, at that time I was not there, but Teknokroma was the company that introduced in this year the chromatography in the private industry in Spain. At that time, the chromatography, the HPLC, didn't exist 40 years ago, or only few companies has an HPLC because it was very expensive. And in Spain, I don't know in Bangladesh, but in Spain, if you would like, as a chemist or whatever, to know more about the HPLC chromatography, you could only learn and you could only see these kind of instruments in the university or in some government laboratories. So Teknokroma at that time, we were the company who introduced and who tried and who started to teach the people about the chromatography. I'm talking about 40 years ago, especially the private industry. Pharmaceutical, petrochemical, companies like SES, or other companies that are doing this test. So, the company is a Spanish company. We are placed in Barcelona, but also we have office in Portugal, office in India, especially to cover better the pharmaceutical market, and the rest of the world. We are dealing with distributors. Here in Bangladesh, we are dealing with Chemtech and all the team of Mr. Roshan and Chemtech. This is pictures of, for example, we have we are producing challenge filters in Barcelona, challenge filters that are validated for HPLC. So this means that before to launch the challenge, each new batch of challenge filter to the market, we check the challenge filter with methanol, acetone, and water at 3 different wavelengths, and we measure the absorbance before and after to guarantee to the customers that really the membrane will not have any kind of extractables or cross-contamination or interference with the mobile phase that you are using. That in HPLC the most common are methanol, water buffers, right, aqueous buffers, and acetone. So this is a picture of the export, and this is my boss, also my boss, is the president of the company. And anyway, I mean, he always is giving support to us to export, and also he knows Mr. Roshan for a lot of years. This is some pictures of our laboratories. I will skip because then we will see faster, sorry, in more detail. We, in Spain, in Teknokroma, we manufacture HPLC columns and GC capillary columns. HPLC columns, as you know, there are several HPLC column manufacturers worldwide. In GC capillary columns, there are only 11 companies in the world that are manufacturing. So it's a challenging product to manufacture in terms that also to have reproducible batch of several capillary columns. It's not easy, okay? And there are only 11 companies in the world. In Europe, from 3 years ago, we are the biggest GC capillary column manufacturer, the biggest of Europe. And it has been hard to us to achieve it, but we are proud of it, okay? We are quite known in Europe, also in South America, in Middle East, and we are here also with the help of Chemtech to be more known in Bangladesh. We have been already supplying through Chemtech HPLC columns and GC capillary columns. Some of you are already working with Teknokroma, but here we are here in order to show how we could collaborate with you and which is the technology of our products. This is a picture of the sharing filters that we are manufacturing. We are the only company in the world that is printing in each sharing filter unit the batch number. Because this was coming from some German pharmaceutical companies and also requests coming from some Spanish pharmaceutical companies that to have a better traceability, they would like that each single sharing filter unit could be identified also by the batch number, okay? Not only, normally sharing filters say nylon 0.45, right? Or there is a color, but also the batch number, because then the user that is filtering the sample can take note, the lab technician can take note about which has been the batch number. And then this is good for the traceability. In the same way that when you prepare a standard and you need to inject in the HPLC, you know, you don't do, let's say, in a random way. You, for example, you're doing a specific HPLC instrument, right? And this HPLC instrument has a serial number, right? And it has been validated or not, but I mean, all it's registered. And then you do with a column. And this column has a serial number, right? So you can write, let's say, in your data. And then you have done a standard. This is standard. You have weight, for example, 10 milligrams. And this standard has a batch number and has a traceability. And then, a lot of years ago, we thought, also, because this request was coming from the pharmaceutical, so from your side they say, come on, the first thing that the sample is in contact with when you do the injection is not the HPLC column. I mean, when you do injection and you see the chromatogram, if something is wrong, we are, me also, okay, as a chemist, okay, in the past when I was doing chromatography, let's say, now I am on the other side, perhaps it's the dark side, I don't know. But normally, if you see something that is wrong, you say, oh, perhaps the column is not good, perhaps there is an issue with the HPLC system, whatever, right? But the first device that your sample is in contact with, before to go to the to the system, is the filtration, is the change filter. Okay? And sometimes, when you need to develop a method, you need to check, you know, the membrane, that there is not any interference. But then, when this method is in routine, you are, let's say, using a lot of challenge filters. Sorry, sometimes it's not easy for me to handle this, okay? Sometimes I realize that you can hear my voice very strong, and sometimes not, okay? So, I'm sorry. I'm not a singer, not a professional singer, and I will try to do my best. So it's clear, the point. And then, some of these pharmaceutical companies get inspections, audits, okay? Always you receive an audit, it's a nightmare, okay? Because you say, come on. And then we decide to purchase a second machine, and in the second machine, we write the batch number. And then a user take the challenge filter, see the batch number, take note of the batch number, and it's traceable, it's clear, okay? Because also if you prepare the standard, you are doing in a balance that has a serial number, that it has been calibrated, you know, all it's except the challenge filter. So as our philosophy, we understood that it was necessary to do it with the challenge filters, and we are, last year we manufactured 2 million units of these challenge filters, validated for HPLC and with this batch number, okay?
So this batch number is unique for each filter, or the common batch number printed in each, not batch number?
Okay. You would like that I say your question to everybody that can hear, or you would like to say by yourself? Okay. Your name?
My name is Khalid.
Caleb. Who knows Caleb? Somebody?
Yes.
Perfect?
Yes. Yes, sir.
Perfect. Can I say the name of your company?
Yes.
Yes. He is from Square Pharmaceuticals. I guess that a lot of you know this company? Yes? Okay. Thank you for your question. He's asking, say, okay, about each batch number, has each single filter unit a different batch number, a unique batch number that is belong to each challenge filter? To reply to your question, I will, when I finish this, I will show you 2 slides and then you will understand. I mean, the issue is that we realize that in the laboratory there are several kinds of challenge filters, because perhaps for one method you are working with nylon and other method you are working with PVDF, right? And at the end, all of us, me too, we are human persons, okay? And the humans, sometimes in the daily work, it's easy that to be confused or this kind of things. This is happening to me a lot. So, you can take one challenge filter from a place, but perhaps it's not from the challenge filter box. You know, there is a box with the challenge filter, and outside of the box is the label, say the brand of the challenge filter, the membrane, the pore size, and the batch, right? And then you take, and I have seen this in laboratories, perhaps one lab technician asks to the other, this challenge filter, what is? Is nylon or it's PDF? Which color is? Oh, okay. And they use, right? And perhaps, because they have a lot of work, right? And perhaps, so there, in this challenge filter, you can see which challenge filter is, and also the batch number. Because when you have a lot of challenge filters, perhaps it can be an issue with a specific batch number, but is a way to be sure which batch number you have used to prepare your standard or to filtrate your sample. I could reply you better with the image. When I finish this, I will go there. Okay? But very good question. Yeah? Any other question about this? No? Okay. This is our sample preparation product line, challenge filters, and this is filtration vials. We will see you later. Everybody of you is working with filtration vials. You say perhaps what? Everybody? Not everybody, sorry. Somebody of you is working with filtration vials? Or, yeah, you are working with filtration vials? Yeah, who else? Nobody else? Can you explain to the rest of the people how you are working, if you don't mind? Yeah, no, I will give you the microphone. Don't be shy, okay? I think it's important. Which company, which is your name, sorry? Oh, I prefer that you pronounce, because if not, I will destroy your name. And okay. And you are working which kind of company? Pharmaceutical. Generic pharmaceutical. General pharmaceutical. Sorry. Okay. Can you explain them? Then we will see some slides. Can you explain them what is a filtration vial and why you are using? Would you mind?
Assalamualaikum everyone. Actually, we all are using the filtration samples before HPLC vial. We all know, I think we are not understand the extent of the speaker. I think we all are using the filtration sample, no? Yeah. Before HPLC run, we filter the sample solutions through series filter, and we are using in HPLC machine through approximately 1.5 ml vial. I think the speaker asked for this, right?
Yeah, no.
Filtration different.
Okay. Do not worry. I mean,
Filtration vial, perhaps we are wrong in the same, in the way that we have put this name, filtration vial, okay? Perhaps we are wrong. Filtration vial is a vial, a 2 ml vial that filtrate. So you filtrate the sample without challenge filter, okay? Is that you are doing Catalan or not? What do you think? Have you a vial that you put the sample and you filtrate, and then the filtrated sample is placed in a chamber that then your auto-injector is taking this? This is what you are doing?
So we filter the sample and the filtered vial, and the vial is kept in HPLC.
I will show you now, because I guess that the picture will let you know to understand better. I finished this part only saying that Teknokroma as a company has 46 years of history, and since 1995 we start to export, and nowadays we are exporting more than 70 countries worldwide. And the job of Gemma and my job, and also job of other colleagues of export department, is try to do this kind of events. In this case, we are here in Bangladesh with Roshan that we know for a lot of years, and try, to explain what we are doing, what these strange people from Spain is doing, right? So this is what we are doing. I will reply to your question, and also about the filtration vial. Only to put on the table, let's say, but all of you already know, there are some kind of membranes that can be used to filtrate mobile phase or samples that are organic, acetonitril methanol. There are some membranes that can only be used to filtrate samples with an aqueous matrix or aqueous buffer. And so at the end, we have the range from nylon PVDF, polypropylene PTFE, regenerated cellulose, cellulose acetate, ester cellulose mix, polyether sulfona, and glass fiber of 0.45, 0.2 micron. So, here, to reply to your question, our challenge filters can be identified once are outside of the box, because in the box you can identify with the information that is in the label, but when it's outside, it can be identified first. Here you see cellulose 0.22, it's clear. Also, the color identifies, we were the first company in the world who decide to put a color, to put a ring and a color to identify the membrane. Then a lot of companies, especially from China, has copied. And then you see a lot of colors in the laboratory, that it's nice. But the first laboratories that start to see colors, it was in south of Europe, in Spain, because we had this idea together collaborating with some German pharmaceutical companies that they have plants in Spain, and also with Spanish pharmaceutical companies. And then here you can see this batch number. This is the batch number, is all the Sherins filters with the membrane that are inside one box has the same batch number. So this is to identify. I know that this is a Teflon 0.2. Why? I cannot read, but I know because the color. If it's blue, it's Teflon, PTFE. If it's light blue, it's 0.2. If it's dark blue, it's 0.45. And the same, dark red, PVDF 0.45. Light red or pink, okay, it's PVDF 0.2. So you have the batch number, and you can identify this Sherins filter, and then you can download, or you can, I mean, you know, we are manufacturing 2 million units a year. We decide that in each pack of 100 units had no sense to print a certificate, because if you purchase us, for example, 1,000, so this is 10 boxes, why do you need 10 certificates that are the same, right? So it's paper, it's environment, and then the customers, our distributors, can download from our website. So, and then you download the certificate, and you see the absorbance, the several wavelengths, water, methanol, acetometry. Now I will reply, or I will try to explain better than before about filtration vial. This. It's a vial. It's a 2 ml vial, typical 2 ml vial of HPLC. Instead of glass, is polypropylene. So also it's resistant of organic solvents, water of course, acid, basic, buffer, right? And normally, what do you have is, you have Sherins, you have a Sherins filter, and you have a glass vial, right? And you know what do you do, okay? Then, what happens? Some pharmaceutical companies, also some biopharmaceutical companies, sometimes, I'm not saying that it's your case, but sometimes they don't have a huge amount of sample, okay? So sometimes they don't have a 1.5 ml of sample to fill the vial. Perhaps somebody of you are working with vial insert. You know, vials inserts, have you seen? That it's a little tube that it's put in the vial that sometimes has a 3 or 4 legs feet. So it's micro inserts that has a capacity of 300, 400 microliter. I can see that somebody is moving the head, so I understand that somebody of you knows or already is using. So you feel this is a 2 parts. You put the sample here, 300, 400 microliters. It's not necessary that you put 1.5. You put your sample without filtrating nothing, your sample. The same sample that you have in the Sherins. And then you do this. So at the bottom of this part, you can see the color. blue, I know that this is Teflon 0.45. So you do the pressure, and here there is a membrane. And then the liquid that is filtrated go inside the vial, go inside the insert vial, because the auto-injector will take from this part. Got the point? Then, with this, this is done for two reasons. First reason is, you don't have a lot of sample. If you need to work with the sharings, there is a dead volume in the sharings filter, right? There is a dead volume in the sharing, so you are losing in each step. Here it's didn't, right? So if you have few sample, 200, 300, 400 microliters, you fill a little bit this part, you filtrate, it's done. The second issue is that we are supplying to the customer, to you, to your teams, a validated vial. What does it mean? When we manufacture sharings filter, we put methanol, acetonitrile, and water through the sharings filter, and we see before and after there is something, any interference, any contaminant. Here, we do the same. We put ethanol, water, and acetonitrile in the same vial that, well, not in this vial, but I mean in a batch of vials that then you will use. This vial we are doing and the filtration in clean rooms. No dust, so the people eat with gloves, with, in the same rooms that most of you are manufacturing your products, or are you doing any kind of procedure. So here, it's not only that we are supplying a validated HPLC sharings filter for you, it's that also the vial is validated. What's the point? Because we validate the chamber that your sample will be inside before to go to the HPLC. Because the HPLC instrument is validated, the cone is validated. And then we understood that we have experience in validation filters. Let's validate the filtration vial. Okay? Clear? And I tell you that the price, if you consider the sharings filter plus the glass vial and the cap, more or less is the same that the filtration vial. So it's with the advantage that this is, with the first option, it's only validated the sharings filter. With this option, it's validated all. If there are no questions, not more questions about the filtration, any questions? Yes?
Just the previous slide, you have seen that vial that is automatically filtration facility.
You say previous slide, okay. I will move and then you tell me a stop.
This one.
Yes.
So you are telling that you are keeping the sample as well as the solvent in the vial.
Yes.
First, then after completion of your adding, you make a press and the vial, the solution automatically filtered to the vial.
Yes.
So if there is any chance to remain the undissolved particles at the lower part of the vial, and when the injection runs, then it could be possibility for changing the concentration of the solution while injection to injection.
Okay.
So how you can justify this portion?
Okay. You say that, first, thank you for your question. You say that if you are filtrate, if we have to filtrate a sample that has particles in suspension, for example, like, how do you say this?
And granules particles are
Yeah. Okay. Okay. But this problem, not this problem, this situation, it will happen also with the Challenge filter, right? So you put in a Challenge filter, and the Challenge filter, the particles that are bigger than 0.45 microns, for example, are not passing through the Challenge filter, right? Remains inside Challenge filter. Yes? Okay. Here in the vial, how is working? You have here your sample with some particles. But this, I don't know if you can see, unfortunately we don't have a sample with us. There is a little bit of space here, and when you push down, if there is any particle, remains in this part. It's not going inside. It's not going inside this part. Okay? Yes?
still some solvent maybe remains in the lower part of this, you are seeing the portion. So
Yes.
solvent, you are saying that the particles remains the
Yes.
gap portion.
Yes.
But the solvent is in contact with the solution.
The solvent is in contact with the solution. I want to understand you well. What you mean? Or somebody?
Excuse me.
Yes.
You want to say, understand, you will put total set in the SPLC system with this tube.
Yeah.
Yes. You want to say the 20 microliter will filtrate in the tube.
Yes.
The remaining portion
Yes.
will keep in the tube.
Yes.
Is there any impact of the remaining solution to the tube when it will inject in the SPLC?
Ah, okay. No. I mean, you push down,
Yes.
and then by force, in the same way that you do the filtration in the challenge filter, you do a force with the plunger, right, of the challenge.
Yes.
So here, the plunger is itself the vial. So when you do this, the filtration, it's here, okay? The issue is that this vial is one-use vial, same as glass. So once you have done and one injected, it's the same as, I guess that nobody is cleaning the...
Actually, we want to say, we put the two portion in SPLC, one portion in SPLC during the operation of the SPLC machine. Please clarify which part we put in the tray of the SPLC, two parts or single parts?
Sorry, now I understand you. No. These are two parts at the beginning. You put the sample here. You do this, and then you have one part.
The spoolage and
And
one
you
single
put,
part.
and you put in the auto sampler. That's all. That's all.
During injection, you are using the only one part
One
or
part.
two part.
One part.
The sample you put at the bottom part. You fill, right? You take this with your permission. This is a courtesy of WITEC. You have the sample. You do this. 300, 400 microliters. At the end, in the HPLC, you will inject 10, 5, 20. And then, this is empty. This part is empty. You press down, this part is empty. This part starts to be filled and finish like this. And the height of this is the same height of a glass vial with a cap. And then you put in the auto sampler. That's all.
Do you have any video of this server support this well?
I guess that has sense that because the people from back perhaps it is sleeping, I don't know, but they cannot hear. If
Yeah, feel free. So, you say.
No, I'm asking that whether this wire will support the circular SPLC
Tray.
tray.
Yes. Yes.
So one thing I want to know, why we use this type of wire? Is it time consuming? That it save the time? Is it cost efficient?
He's already mentioned that is cost effective and also low volume of solution.
yeah, is there are two reasons. One reason is that there are some pharmaceutical companies, especially biopharmaceutical companies, that they have some people that has to inject peptides or proteins, or even in the university, or sometimes you don't have 2, 3, 4 ml of solution of peptides. You have few. If you need to filtrate with the Sherrin's filter, and a Sherrin's filter has a dead volume, standard Sherrin's filter has a dead volume of around 100 microliter. So if you have 400 microliter, in the first step you lose 100, and then there is a part of sample that is in the Sherrin's. So you lose sample, you lose. I mean, there is no option. You have to lose. There is a residual volume of sample in the Sherrin's, a residual volume of sample in the Sherrin's filter, and then also you have to vial to work with a glass insert, because if you work with a standard vial without the glass insert, it will be in the bottom, and then the needle of the auto sample will take air, because there is not enough level, right, of sample. Okay, so from a point of view of cost, I say you it's more or less it's the same cost. Okay. The advantage is that this kind of vial doesn't matter the volume of sample that you have. You only need to filtrate 300-400 microliter. That's all. And the second advantage we consider is that when we have to validate the membrane, the membrane, the filter, at the end we validate all the chamber of the vial. So all that your sampling will be in contact before to be injected. So if there is an issue that sometimes you say, oh, perhaps it's the solvent. You go to the solvent, you go to the bottle of methanol, and you see which is the batch. You can ask to the manufacturer which was the COA of this batch, and perhaps it was impurity or whatever, right? So also it can be done with the vial and the filter, okay? Because we validate for HPLC. We have checked before that is a safe place for your sample. Clear? More questions? No? Yes?
Leasing is a big issue. There are many research, symptom, students. Leasing issue started.
Leaching.
I don't got the point.
Leaching means any reactions with the step one with the solution. Is there any research? You have any data?
Data? Not here, but
Leachable, it is leachable and leachable is asking that
structural.
solvent sector.
Okay. Yeah. I mean, I don't have here, but there is a compatibility of solvents and samples of all the materials that we are using. At the end, the material that we are using for the vial is the same material of your Sherrin's filters you are working. So you are working with two materials. I mean, I don't know, but I imagine, right? Vials, I guess that all your vials are glass vials, right? Glass vials.
Septum is not
Yeah, no, yeah, wood. He says, septa is not glass, it's true. It's true. It's normally silicone or it can be rubber with PTFE. So, the septa is silicone with PTFE. The same, and the cap is a snap cap, the same that you have with the vial. So here, what I'm saying is that this material, that it's polypropylene, it's the same material that the challenge filters that you are using is the first material that your sample is in contact. First it's with the challenge filter, and then it's in contact with the glass of the glass vial, and the needle is touching the silicone and Teflon. Here it's the same, but it's not the same. There is no glass. It's the same material as challenge filter, and we validate because we validate the filter, but the filtration is inside the vial. We also validate the vial. So with the other, you have a glass vial that it's clean, and it's good, right? But some customers say no, we want to. I mean, we have to validate the filter, and at the same time, indirectly, we are validating the vial. Okay? More questions? Yeah?
As it is first time.
It's the first time, okay?
Is there any sample with you?
Not here. Not here.
Then it will be very helpful for us to understand.
You know, I will explain you, let's say, to do a.
It would be better if you can show us some video about this fire.
Okay. Yes. Yes. You will. We will send you. Chemtech will send you the samples. And and also we will share with you a video. The issue of the samples, I explain you curiosity. When we, for example, this trip, we have taken Germany hand luggage. Okay, because to come here we have done Barcelona, Doha, in Qatar, okay, with Qatar Airways, Doha, Bangladesh, right? And then tonight I need to be at Mumbai, and then I do Dhaka, Chennai, India, Chennai, Mumbai. Why I explain you these kind of things? Our intention sometimes, in order to, it's that we avoid to have to go with a big luggage that you have to check. And then what is happening? That, for example, if we get, I can see the glass, the baker, the mayor, the bottles. There is no issue with this. But if we bring with us an HPLC column, this can be considered by security of airport worldwide as a knife or as a tool. You can, I understand, right? And then at the end, for that reason, we decide not to take the sample, the backup samples, and unfortunately we don't have the filtration vials, but we will send to you some samples, okay? So we will say to our colleagues of Chemtech which membranes you are working with, because we don't know. So if you say nylon PVDF, and then we can send you a box with a pack of 100, and you can try. And you will see that it's working very, very fine. The people, the users that they have tried, then they want to, because it's very comfortable. Yes, sorry, I forgot you.
Actually, I have a question because I have experience to use this.
You have experience to use this, yes?
I have a question because of if the sample have the This water and organic layer
Yes.
cannot separate together. This sample can be used for this for filtration.
Okay. I don't know if everybody has asked the question. Every time, at the beginning it was easy questions, and every time it's, I'm joking. Yeah, he says that if you have to filtrate a sample that has two solvents that cannot be mixed, okay? Is a real example that you have, or it's?
Yes.
Yes. Which one? Can you tell me the solvents?
Yes. Sometimes we have ethanol
Ethanol
and have the buffer.
and the buffer.
And we shake together and it's make the gel form. It's make a gel.
Yes, a gel. Yes. Thank you, Mr. Rocha.
Yeah. It's made a gel. So this
Yes.
kind of sample, sometimes you have to do the very difficult filtration.
Okay.
So in this case, we use this filter for the.
Yes. I mean, when you do this, sorry, but now I need to ask
Okay.
to you. Okay, to be fair. Okay, you say a solution that has buffer and ethanol.
Yeah, it's
Okay.
combined together, have a mix.
Yeah, in
Gel.
theory,
Yeah.
water and ethanol are soluble, okay, but in the laboratory sometimes, depending on which compound you have, okay.
It's a matrix also.
Yes.
Matrix effect,
Yeah, matrix effect, okay. So, and then, how you filtrate? You do with a Sherring's filter,
Yeah, most of the things.
and which is your experience? I mean, do you find problems with
Yeah, it's
the
not
filtration?
passed through the filtration unit.
It's not passed through, okay. Which
So-
membrane you are using?
Membrane.
Yeah, which membrane material? PTFE?
PTFE.
Okay. Okay. I thought, but right.
Which case it can be helpful?
No, I tell you. The issue, in fact, PTFE, right? And then I will explain you why. What is going first to be in contact with the PTFE? The ethanol or the water? You know what I mean? You put, right? And then what do you think that first is in contact? The water?
Ethanol.
The ethanol. Okay. I say that the PTFE is the only membrane, as I know, that is quite used. In the pharmaceutical. You are in a pharmaceutical.
No, I'm from analytical laboratory.
Anyway, but at the end, the chemistry it's the same, right? So, come on. PTFE, it's the only membrane that as itself is hydrophobic. What does it mean? PTFE, as all of you know, when you are in the kitchen, you use a pan, right? A pan? Okay. The pan, in order that your meat or vegetables, whatever, do not stick to the pan, is a layer, is a film of PTFE. Okay? And PTFE is very hydrophobic, so don't want to be in contact with water, right? It's water is not a friend of PTFE, and you can. But I know that a lot of customers has these problems, right? So you can filtrate aqueous samples, but it has to be first the PTFE activated with alcohol. Because if not, I mean, what is happening to you, right? You are not doing nothing wrong, okay? You are doing, the issue is that it's difficult because the PTFE has this problem with the, I don't know in English, a revelation. It's a big forces, right? That the molecules that they don't want to be in contact with PTFE. And here I could see two solutions. But this issue, it will be the same issue that if you have with the Shannon's filter or with the filtration vial, because at the end you have to be in contact with the PTFE member. We have, it's not here shown, but we have PTFE hydrophilic. So it's a PTFE that is with a little bit of modification in order that to work with water without having to prevent it with alcohol. For that reason I say you, what is the first that it's in contact with? If it's alcohol, I mean a lot of customers that if they have to work with PTFE as a must, because the method says you need to filtrate with PTFE, and unfortunately they have water, you know why they have to filtrate PTFE? Because PTFE is a very resistant membrane for acid and basic solutions. So if you put nylon or PVDF, perhaps the sample can dissolve the membrane, okay, can destroy the membrane. So has sense, right, that you are doing with PTFE, or there is a method that says that with PTFE. But really, if you are, I will say to you, I can see two options. One is, instead of PTFE hydrophobic, use PTFE hydrophilic directly, or the option that I will do, if I were in your skin, it will be, before to filtrate your sample, take pure or doesn't matter, I mean, take ethanol and wet first to activate the membrane, right? And then try with your sample. And then see if really you can filtrate better. I have no idea about how complex is your sample, but when you have explained me, I was thinking, I guess that you are working with PTFE, and then I have asked you, and you have confirmed me. So it's this, okay?
Yeah, but if we activate, then it will dilute the sample, right?
Ah, yeah, of course. Yeah, no, for that reason, I say that there is another option. Okay, but you can activate, but with a very few amount. Okay. It's not necessary to put 2, 3, 10 milliliters. So the dead volume that is inside the Shannon's filter, it's around 0.1 ml, 100 microliter. So if you put 200 or 300, I mean, I will say, place inside ethanol until you see a first drop of ethanol is going out. When it's going out, you are sure that inside it has been wet. And then you wait for a while, and then you put your sample.
Okay. Thank you.
Or
Yeah.
with PTFE hydrophobic that we have. I mean, if you would like to try, ask to our colleagues of Chemtech, and we can send you, we can supply you PTFE hydrophobic.
Yeah, that's good. Because hydrophobic can be helpful. So maybe
Yeah.
you can try it, because we have already these sheets in our laboratory. But sometimes we have to face this problem to separate the layer,
Yeah.
the organic and inorganic. So it would be helpful.
Okay. So as I said before, thank you for your question.
Thank you.
Contact later with Chemtech, and we will try to help you if we can, of course. Okay. Let's talk about HPLC. We should do it. The time, I know it's the time that we are late on the schedule, but also at the same time, I appreciate all the questions that has come from you, that were not from HPLC, let's say columns or GC, but also are linked with the chromatography. So I have tried in order to reply in the best way. And now let's have a look on the HPLC column range. Good. Only to show you. Perhaps somebody of you has the curiosity to know how an HPLC column is packed. Here, there is a picture of our production laboratory in Barcelona. And this is a zoom of, here is two columns we are packing. One of 15 centimeter length, another one of 25. So we prepare, we call a slurry. It will be like a suspension with some organic or aqueous solvents, and then a certain quantity of silica. The silica can be 1.8 microns, 2.2 microns, 5 microns, 3 microns. And then we place inside, and we are able to pressure up to 1,200 bar. Always, this is to avoid that if we would pack the columns at the pressure lower than the pressure that you are working with your instruments, then what will happen is that you will repack, you will compress more, the columns. So we pack at a higher pressure, doesn't matter which instrument you have, and we check that there are no leaks, and then we check the performance. Nowadays, or last year, we have two working chiefs in the HPLC laboratory, and last year we manufactured around 32,000 HPLC columns. So we are selling worldwide, as you have seen before, and also some of you are already working with our columns. We will see here it's some pictures of our quality control. We do the silicas, we do the bonding by ourselves, we pack, and each single of these HPLC columns are tested individually. So all the columns that we supply, are tested in Barcelona. We test the silica batch, and with one silica batch, perhaps we can manufacture, I don't know, 50, 100 columns, 200 columns. Each one of these 100, 200 columns are tested. We consider we are a flexible company, a medium-sized company. In Europe, in HPLC, as the information that we have, we are one of the top 3 HPLC column manufacturers, and the biggest column manufacturer of GC capillary columns in Europe. And we have been manufacturing HPLC and GC capillary columns for 35, 40 years. I will ask to show you very quickly, because I want also to have time to talk about GC capillary columns. Let's say our premium line of HPLC columns is Bella. I guess that this, yesterday somebody told me that this was a Pal. Pal, it's the name of a sailboat. A sailing boat. Sailing boat, okay? So this part of the sailing boat, in Spanish we call Bella. So it's a big piece of, I don't know, of cloth, and we call Bella. And this is the name of the column. All the columns all the names of our columns are linked with the sea, with the Bella, because Barcelona, you know, it's in the Mediterranean, and we feel very close to this. I will go directly to the point. There is no time to explain you all the columns, but I want to explain our philosophy in order to launch a column to the market, especially for laboratory analysis pharmaceutical companies. Sometimes what is happening is that, for example, let me ask, how many of you in your companies has UHPLC instruments? Can you UPLC or UHPLC, right? And anybody of you have, let's say, for example, a significant, I mean, normally, my experience is that there are some pharmaceutical companies that they have UHPLC, but the most used is the HPLC, right? In terms of applications done, methods, in terms of instruments, right? But there are some pharmaceutical companies worldwide that from several years ago that they are doing, the R&D departments especially, they are developing methods with UHPLC instruments. So they need also UHPLC columns. And then the limitation that sometimes we know that it's happening for the pharmaceutical company is that the R&D sometimes transfer this method to a QC internally, and QC can have UHPLC or HPLC. But sometimes these products or the license, the product license, are sold or there is an outsource of another pharmaceutical industry in the same country or in another country. And then perhaps HPLC department has done a big effort in order to develop a method with UHPLC or with HPLC, but then when it's transferred this method, imagine that you have developed a UHPLC column, an instrument, and then on the other company or on the other plant, at that time they say, we don't have enough UHPLCs in QC in order to proceed with this. We have HPLCs, and then R&D has to do the work again, right? So in order to make easier this work, all the columns that Teknokroma has been launching from the past years until today is available, the same column, the same C18, the same polarity, the same selectivity, in 1.8, in 3, in 5, and in 10 microns. Doesn't matter which kind of technology you have. So if you want to move from one side to the other, you will have the same column. Okay, different particle size, but the same specifications, the same column. You will not have an issue that with UHPLC, with one column, you have peak A and peak B, and then HPLC, you need to work with another column, and then you have no separation. Or you have separation, but it's first B and then A. That this is happening, as you know, sometimes. Clear? So, for example, this line Bella, we have in normal phase, amino-cyano, L8, L10, we have ilic. Anybody of you is working with ilic chromatography? No? Ilic is something that, I mean, it start to be used in the universities. Some people that is working with LCMS, they are also requiring this kind of columns. We are packing this kind of columns. Are not yet recognized by USP or by British Pharmacopoeia or European Pharmacopoeia, but I guess in a few years it will be. And then there is the reverse phase. We have several types of C18, more than you can see here, C18 with a low carbon load, that are good to work, for example, with polar compounds, with 100 aqueous buffer without collapsing the C18. We have also C18 trifunctional. So this means that in the silica, instead of being one chain of C18 in each point, we can have 3 C18 chains. It's L1, it's a C18, but also sometimes this gives a different selectivity, and sometimes it's good for your applications, for impurity, separation of impurities, this kind of applications. As you can see, we have all of these are C18, but are different. I think that your companies need C18s because Pharmacopoeia says L1 C18, but C18 is like I want a car, but then the car is a car because it has 4 wheels, but the car can be white, it can be red, it can be with 3 doors, 5 doors, it can be electric, it can be gasoline. So here is the same. We have several kinds of C18, and when you have an application or when you have to develop a new method, ask to us if you want, because we have experience. We have people in Teknokroma that has more knowledge than me, okay, fortunately, of HPLC, and they have been working in the pharmaceutical industry in the past. So they understand your needs. They know the way that you have to work, that you cannot do the things in random way. So it's the audits, all of this environment that it's for me it's one of the industries more checked by everybody because the products that you are doing are going. Anybody is working with gauge columns? Would you like to explain to the people? I prefer that you explain, if you don't mind. What is the gauge column? What it's used for? Yeah, would you mind? Thank you, sir.
We use gauge column in the HPLC liner. Basically, its function is to clear the baseline, just inline, no spikes comes out except the APIs. Questions?
Is the gauge column used before the column, like
before the column in the liner?
before the column? So it is a pre-column.
It's one kind of pre-column. One kind of pre-column.
Yeah. No. It's the difference between. Can you hear me? Yes. The difference. No. Okay. Thank you. The difference between work column or pre-column. The pre-column and the work column are placed just before the HPLC column, but after the injector. So the pre-column, as my knowledge or as my experience, also we manufacture pre-columns, okay? When you inject your sample, for the people that it's in far and cannot see, here you have the module phase, the pump, the mixer, if you are working with isocratic or radiant, okay? And here there is the gauge column as our colleague or, from a square, right? A square pharmaceuticals. Here is the gauge column and here is the injection. The sample is here. So look, the pre-column or work column, it's between the injector and the HPLC column. What does it mean? That this pre-column is working in order to trap, to catch, or if there is a matrix complex, to retain the compounds that we don't want to, we are not interested in, okay? Or the dirty, you know what I mean? This kind of compounds from the sample. The gauge terminator column is working exclusively. Somebody has wake up now. Is working exclusively on the mobile phase because the sample is here, not here. So it's a purifier of the mobile phase, and the name of GHOST is to try to avoid, to try to trap the ghost, the unknown peaks, impurities, whatever, linked to the mobile phase, not to the sample. Especially, which kind, perhaps you have stated, which kind of instruments you are working with ghost columns? In any kind of instruments, or perhaps LCMS or HPLC, standard HPLC. There are a lot of customers worldwide, a lot of technicians, lab technicians like you, that in LCMS it's like a must. They have to work with ghost column because they need to be sure that the mobile phase that is in contact with the HPLC column is pure. I mean, they spend a lot of money to purchase a high purity solvent, and also they need to be sure that before the sample, if there is something not wanted, it has been trapped by the ghost terminator column. So we have, and yes, as I said you before, remove impurities with low or non-polarity, impurities from the solvents, and purify, let's say, the mobile phase and also the system, the connections, before that the chromatography starts. So these help to avoid ghost peaks in the chromatograms and also improve the column lifetime. So we protect the column with the pre-quart, the pre-column against, we protect against the complex of the sample matrix, and with the ghost, we fight, let's say, or we take the impurities from the mobile phase. Any other question about HPLC?
Ghost column packing.
Ghost column packing?
What kind of packing do you use in ghost column?
Yeah.
The certificate there didn't mention the ghost column packing. So
Yeah.
can you
No.
explain?
Yeah. Okay. The issue is because we have only 20 minutes. I need to talk a little bit about GC. Yes, I mean the cost, our cost, we call cost terminator. Terminator, I guess that it was an idea of marketing of this movie of Terminator of Arnold Schwarzenegger. I guess that some of you knows. So it was cost terminator. Yes, it's not a silica backing at all. It's not a silica backing. It's a backing of, let's say, graphite, charcoal. Is especially linked to take the non-polar interference, pollutants from the mobile phase, and we certificate. So we do a test on each single column we are manufacturing. Okay. So are very short columns. These columns are columns of 5 centimeters or 10 centimeters. Are very short column, but to remove these impurities, you don't need a 25 centimeter column. So the ghost columns, as this guy, I forgot your name, sorry, from Square Pharmaceuticals, are used in HPLC, in UHPLC. It's to try to optimize the efficiency of the system, to work better, to avoid to have surprise. So really, I find every trouble that we do with the GEMA worldwide, I find more and more people that are working with this, with the cost terminator columns, because are very useful. Are you shy? No.
can we use this column for the same size, for bigger sizes? This 80 columns.
Ah, yeah.
We use our delay column.
Yeah. Which one? Deal.
Delay column, like go to big diameter, you already say.
Yes, yes, yes. Okay. Okay. Yeah.
Thank you for your question. So you are working with LCMS? Yes, LCMS and S. Okay. Yes, we have the UHPLC and HPLC columns. It can be used for LCMS and S. Okay. Yes, we have, let's say, in different internal diameters. We are producing in 0.2 millimeter. 2 millimeter, 3 millimeter, 4 millimeter of diameter, right? 4.60 millimeter. So we have for the most used UHPLC and HPLC, and also for UHPLC and HPLC and SMS. We have. Yeah? The standard, you mean the column itself, right? The column. Also we have the loss terminator columns.
Like delay columns.
Right?
Delay columns. Any contaminants or like this?
Yes, yes. So yeah, we have. It can be used for HPLC, for LCMS. Yeah. Okay, welcome. Who was working in GC? Can you, GC, gas chromatography? You, and you. Which sector? Pharmaceutical? Textile, testing lab, textile. What else? Textiles. And leather. Okay. So let's have a I will try to do my best in 15 minutes. Gas chromatography. It's pharmaceutical, but also it's another, also textile, leather. So I will go immediately to the point. It's only for your information. We manufacture GC capillary columns, we manufacture GC packet columns, and also we manufacture GC micro packet columns. The only thing that we do, no, we do a lot of things, but the only raw material that we buy is the silica tubing. We buy the silica tubing, and then all the phases, all the silicones, we have the chemist, and we synthesize, we do the synthesis of the stationary phases. 1, 5, bags, 624, G43, whatever. For food industry, for pharmaceutical, for textile, for any kind of, we'll see applications. Jumping, so, yeah. We have columns for FID and ECD detectors, and we have columns for MS detectors, and then we have ultra-inert columns for MS detectors. So, and also we have for high temperatures. This is especially for gas and oil. You know, in pharmaceutical and in other sectors, normally, when you are working with gas chromatography, the standard columns can achieve, in the oven of the gas instrument, can work until 300, 350 Celsius. But because at this temperature, the majority of the compounds are volatile and can be, you know, the gas chromatography, I mean, HPLC is, the module phase is liquid. Gas chromatography is like HPLC, but instead of liquid, it's a gas. But at the end, it's a chromatography. It's a thinner tube, right? And when you need, for example, to do analysis of asphalt, you know, asphalt, yes, it's correct. What is in the roads, in the highway, that it's coming from the petrol, yeah? This is very These are very heavy compounds, very heavy compounds. And if you try to heat that to 300, it's not completely volatile, okay? Or there are some compounds from textile or from some other different materials that are used in pharmaceutical that you need, in order to elute, you need to work until 400 or 430 Celsius. And for that reason, we have also the columns for HD, high temperature. Let's have a look at some applications. We have all the range, 1 phase, 5 phase, the phase used in pharmaceutical, like 624, G43 to see volatiles of solvents in drugs, in raw materials. And let's see some examples. I jump all of this. I jump all of this. And I will finish with this. These are several applications that we have for the industry. For example, the chemical industry or the biological industry, they have to analyze amino acids, solvents that they are manufacturing solvents, impurities in solvents. When the pharmaceutical industry is purchasing a methanol of high purity, the manufacturer of the methanol, the way that, or one of the ways that he is measuring the impurities and how pure is this methanol or acetylithyl, that is not cheap, the acetylithyl, as you know, it's very expensive. So the way that they are doing the COA, that they are doing the QC test, is gas chromatography. So you test, I'm talking about pharmaceutical companies, you test the quality of your products, of your API with HPLC. So the solvents that you are purchasing, the manufacturers of these solvents are using, for example, GC. And it's most common to use GC. Here there are some examples. I will, environmental. If you want to analyze dioxins, furans, PTX, PCBs, polyaromatic hydrocarbons, pesticides, solvents in water, volatiles and pollutants in water and soils. For all of these analyses is used more gas chromatography rather than HPLC. Evaluation of pesticides. For example, in pharmaceutical industry, it's true that there is a lot of HPLC instruments, but in all the pharmaceutical industries, as I know, they have to do some analysis with the GC. And if pharmaceutical industry do not have a GC instrument in the lab, perhaps it's because it has outsourced this analysis to a third party, to a private laboratory. And I'm sure that all of you know that you need to control the impurities as pharmacopoeia is required for the alcohol 96, or impurities of, for example, of saccharin, or check that the residual solvents in the raw materials that you use to produce your drugs are below the maximum limits indicated by the authorities. So here we have some examples: alcohol impurities required, in this case by European Pharmacopoeia. Then we have here for example, the petrochemical. I guess that nobody's from petrochemical. I will jump. And then somebody's working with food and flavors industry. Somebody here is working food and flavors or has to do this analysis? No? Okay. So that's all. 10 minutes before. I should finish at 12:30. I don't know how I have done, but it's 12:20. I think that we should stop here. So if there is any question, now is the time. Any question? No? Fantastic. So thank you. Yes, one question. Yes, thank you.
The last slide, do you have it?
Yes, I have understood last slide, but
Last slide.
from this presentation, last slide. Okay. Which is the last slide?
It shows amino acid. One slide, there is amino acid part.
Sorry.
Amino acids, actually, you are providing images like amino acids.
Amino acids. Do you have any amino acids?
Amino acids.
Related to
Amino acids. Sorry. My pronunciation of English is bad. Okay. In GC, you say?
Not actually.
Amino acid in GC? No, it was HPLC perhaps? Okay, HPLC. Right. Very sure. No. Okay. Whoa, fine. Can you see? You mean this?
Yes.
Amino acids. I don't know if I have here, but if I have, no, okay. The specific chromatogram I don't have here at this presentation, but I have.
What I was saying that we are working with amino acids ethanol, one product, but it is struggling with math. We have actually no proper method for separation of different types of amino acids.
Yeah, amino acids, it's not easy. I mean,
So I think, do you have any suggestions to the column?
Yeah.
For this purpose?
yeah. Are you doing derivatization of amino acids or not?
We are using a method which is the derivatization method.
Yeah, I mean, it's only to how you are working now with which method, which column, which kind of technology you are working. Or you have to start from zero.
We are using one method, Zorvex column, like
Zorvex?
Zorvex.
Yes.
Zealand Zorvex.
Yes, I know. It's a rubber space, it's a CAD, or it's okay. And the problem that you have, it's for any specific amino acids group, or it's understand. I mean, you have explained me very well your question, right? But it's to understand more.
Actually, this method is provided by supplier.
Okay, by the supplier.
Actually, they are using some derivatives method.
They are using derivatization. Yeah. Yeah.
But after using this column, separation between
Okay.
and after a certain time.
Which detector you are using? Okay. The other right. Yeah. Okay. Photo the other right. Detector. Okay. Okay.
We cannot find a solution for it.
Yes.
After a certain time, things are marching and their response are gradually decreasing.
Okay.
Okay. For this, we want a solution from this column.
Yeah. Okay. Yeah, the question from there, you know, the amino acids that we have millions inside of our body. Thank you for your question. Okay. This, for me, as my knowledge, it's one of the most difficult, let's say, separations that it's not easy. Okay, it's not easy because it's complex. Sometimes you need to do a derivatization of the sample before injecting. So it's not easy as take the sample, inject, right? So I suggest you to contact with Chemtech, give all the details in the way, I mean, I guess that more or less I know the way you are working because you have already told me that, but first I need to know which difficulties you have, then I will internally evaluate with colleagues, my colleagues of Teknokroma that also they have more knowledge than me, especially in this kind of applications. And then I will let you know whether we can suggest you to try something or yes, because I mean, amino acids there are several, right? And I need to understand which ones you are interested in. Okay? So please send all this information to Welsh, and when I arrive on Thursday morning, I will be at Barcelona, again at my home, okay? We will be at our home with family, children, and then I will have a look, and I will try to do my best in order to help you, okay? Sorry? Yes, yes, yeah, no, but I mean that it was only to you know, also to give the opportunity if somebody else would like to ask. Of course, later, during the lunch, or we can discuss
Yes,
more
yes.
detail, right? It's only, okay. That's all?
That's it.
Yes? Okay, so it has been a pleasure. Thank you. I know that to be 2 hours here seated, hearing one person from Europe with an English accent that is, you know, it's not easy, it's hard. I guess that nobody has slept, I guess, that everybody is with open eyes. So I have, it has been a pleasure for me. I have learned a lot with the questions that you have asked me, honestly, because you make me think, and okay, so I appreciate. And we have tried, you know, to do our best. And also I say thank you to Chemtech again for the invitation, for the organization. And thank you to all of you to have decided to come here and to be together with us. Okay? Thank you.
I am honored again. Thank you for Teknokroma especially.